Welcome everyone to Oracle Maximum Availability Architecture Best Practices for OCI. Just to introduce myself, my name is Glen Hawkins. I'm the Senior Director of Product Management for Maximum Availability Architecture, DataGuard, and a bunch of other database HA and DR technologies. Before I get started, our normal safe harbor would apply to any general forward direction or roadmap type of discussion that we have as part of the presentation. So please keep that in mind. And without further ado, I'll jump into the topic at hand. First, before we jump into maximum availability architecture, it's important to understand the downtime and recovery objectives that we're trying to go ahead and address with the solution. So types of downtime include planned maintenance, upgrade, recoverable local failures, unrecoverable or site failures, and such as losing your entire data center or entire region. Now, keep in mind that a lot of times planned maintenance type of activities tend to occur a lot more often than unrecoverable site failure, which hopefully never occurs, but we do know occurs from time to time. As we look at the downtime, what we're trying to go ahead and do is minimize the data loss and downtime, or RPO, recovery point objective for data loss, or recovery time objective for recovery time for downtime. RPO is measured from the time of the occurrence backwards in time. So if you took a backup 24 hours ago, your RPO might be 24 hours, right? You may lose data for 24 hours if it was unrecoverable, the database. RTO, or downtime, is measured looking forward. It's how much time has passed before our application is up and running and accessible again. So hopefully those are seconds to minutes, but it could be hours to days, depending on the type of occurrence, especially in the time of if a site failure occurred. So now that we understand what we're trying to address, we go through maximum availability architecture and what it is. So MAA came out of customer insights and expert recommendations from working with customers just like yourselves. Over time, we had 30 plus individuals that have focused on it. All they do is MAA. There's some of our veterans here at Oracle, and their focus is going ahead and breaking things proactively to ensure all our disaster recovery and high availability features work properly. And we've created a bunch of best practices associated with that. Out of that came 4 different reference architectures: bronze, silver, gold, and platinum. And they map to different RTO and RPO values. The goal isn't to get everybody to platinum. It's not one size fits all. The goal is to go ahead and match the different MAA tier with the RTO and RPO requirements of your application. And those could change over time, and you can go ahead and evolve them. We'll talk about that as we talk about the different tiers. Now, MAA is composed of a bunch of different features which fall into 4 different categories: continuous availability, data protection, active replication, scale out, and lifecycle. And a lot of your favorite features like RAC, application continuity, active data guard, GoldenGate, all go ahead and fit in these different categories. And some of them go ahead and overlap with different features, right, in different categories. And they're all integrated together very tightly. Those features combined with configuration and operational best practices that are listed in our papers and documentation are what MAA is all about. Those are the blueprints, those reference architectures, what we provide to you. And you have a bunch of different deployment choices on that front. You can do generic systems, or engineered systems like Exadata, or our different cloud services, BaseDB, our Exadata database service, all the way up to autonomous. And we're doing more for you as we go from the left to the right in there. We're going ahead and managing a lot more. And how can you get to the cloud? We have zero downtime migration, which is built on top of DataGuard, which allows you to go ahead and migrate up to the cloud without going ahead and experiencing downtime, right? So let's go ahead and talk about the Oracle Cloud Infrastructure Topology so we understand that before we jump into the different tiers. First, it's important to understand there's a bunch of different locations out there, right? So we're adding locations all the time. We have a very, very large global footprint in regards to it. We're talking 40 regions right now. We have 4 more planned on the horizon. 11 of those are Azure Interconnect regions as well, which are important for those of you looking at multi-cloud. And they fall into the category of commercial or government, right? So we have a ton out there. Really important when you start thinking about disaster recovery. And you go, well, here's my primary site, and here's my secondary site, or even tertiary site. And I can go ahead and look at the different options that are available to me. We have a bunch of different database services, a variety available to you, and some provide more automation than others, right? Our base database service that we go ahead and provide, you can do single instance there, or you can do RAC. As we go ahead to Exadata database service, you have RAC is basically built into the infrastructure, and you have the choice of doing cloud at customer and running it in your own data center at this point. The same with autonomous. So we have autonomous shared, we have autonomous dedicated, provide you with even more isolation. And then we have an autonomous database that can run on your cloud customer as well. As we move from the left to the right, we're doing more for you. We're doing more of the MAA configuration. We're setting up more of the A-chain disaster recovery, scheduling, everything is all out of the box, right? You do have controls over it depending on which service you choose, but the idea is that everything is fully managed by the time you get to autonomous. All right, let's talk about the topology, the different nomenclature associated with our different components within our cloud at OCI. So we have regions. These are geographical separation between them. There's a large geographical representation of it. It might be part of Europe. It could be the Western United States. But you're representing a region, and then you have availability domains, which you can think of as independent data centers within there. The difference is that from a latency standpoint, you have very, very low latency between the availability domain. This is important as we start talking about MAA. We start talking specifically about disaster recovery, that under 1 millisecond synchronous replication capability that we have between availability domains provide us with a lot of flexibility that we want for some of those DR configurations. Where regions can be very, very separated geographically, right? And the latency can vary depending upon that distance. And so you may be using asynchronous replication. Not necessarily, you do have the flexibility to choose one or the other, right? And there's also a certain number of availability domains. Some of them, like Phoenix, Frankfurt, London, have 3 availability domains in them, right? Where some regions have 2 or even just 1 availability domain. So it depends on what you're going and choosing, and we're constantly enhancing our story there as well. Now on BaseDB, you also have the ability to go ahead and choose fault domains, and this has isolated power and network. We take care of this for you on Exadata Database Service. In Autonomous, we're going ahead and taking care of the fault domains, so you're not going ahead and tweaking that. But on BaseDB, if you want to go ahead and you want to configure where some of the resources, you have a little bit more control over it with the fault domains. All right, let's start talking about the maximum availability architecture tiers now at this point. How we get from single instance all the way to what we call 5 nines. It all starts with the bronze tier, right? So this is for your less critical applications, but one of the important things to take away from this is the base for all the other tiers. Everything is hierarchical. We're building on others. So platinum and gold are supersets of the tiers beneath them. So the bronze tier provides basically the base for everything else. And while we talk about single instance, right, you have automatic restart still, you have precedence for asset transactions. There's still a ton of capabilities here, right? Online reorganization allows us to go ahead and change our tables online without taking any downtime. We have multi-tenant available to us, right, with PDB, CDB isolation, and we can do a lot of lifecycle operations such as cloning and setting up test environments. And it still provides protection from noisy neighbors. Flashback is our rewind button for the physical database or even individual tables or queries. And finally, RMAN is providing our RPO protection. Now you see this represented in the diagram as well as the outage matrix that we have here, right? So planned maintenance, we never should be seeing any RPO, right? So we're seeing 0 RPO for the planned maintenance across the board for planned maintenance upgrades. Recoverable failures, we can still basically recover the database, so it should be fine. But from an RTO standpoint, we're looking at minutes to hours before we can get back and running when we're talking about this tier. There's no clustering at this time. We're talking about single instance. And then if the entire data center, right, if Godzilla were to stomp on our data center, right, and there was a power outage for the entire region, you would have an unrecoverable failure for the entire region. So you're talking about your last backup at that point. And it could take hours or even longer to go ahead and recover at this point. So that's for our site failure. Now, Silver builds on top of this. So now we're talking about more critical applications. We're talking about also the base for Exadata Database Service, including Cloud at Customer, and as well as Autonomous, always has rack there. And you have your node protection failure at this point. So we have node protection failure. We can do rolling patching at this point. We have a lot of flexibility in regards to scalability of CPU, memory, ASM storage. So without taking any downtime, we can go ahead and make these changes. There's a feature in rack called application continuity, though, that goes ahead and takes care of your in-flight transactions and can transparently go ahead and play those over. So if you have a node that fails in your cluster, it will automatically go ahead and roll over the connectivity, and then it will replay the transactions if you have application continuity configured. So once again, just a feature of rack and active data guard as well. And then if you're talking about ExaDB or you're talking about autonomous, we have engineered systems. Exadata is sitting under the covers and all the benefits that you get there from a scalability standpoint, agility, data protection, all built into it. And we see this represented now in our outage matrix. So the outage matrix at this point, planned maintenance, we have rolling patching. So our RTO has dropped to 0 at this point. Upgrade, we're still talking about hours if we want to go ahead and do an upgrade because we don't have rolling upgrade yet. Stay tuned for gold. We're going to go ahead and address that. But for recoverable failures, if one of these nodes go out, one of the CPUs fail, we can go ahead and recover. We can be back up in seconds. And with app continuity, from your application perspective, it would simply be a brownout, just a blip in performance. Because those transactions would be replayed. They would not fail, even the in-flight transactions. Now, if the entire cluster is wiped out, all the availability domains, the region is impacted by a huge power outage, we're still in the same boat as we were before because we don't have disaster recovery. We kind of have high availability, but not disaster recovery in this scenario. Still, this is a very, very common deployment for many of our customers out there. So, what kind of best practices would apply to bronze and silver? I'm just giving you some highlights. There's a lot more in our documentation and papers out there, but one of the important things to do is to go ahead. We have exit check. It's pre-configured. It's updated automatically. We're running it. So ExaDB, autonomous, it's there, right? Exadata is under the covers. For ExaDB, you have control over some of these best practices. You can go ahead and make some changes under the hood. What exit check goes ahead and does is it automates checking all those best practices for you and highlights anything critical. We're also updating it all the time. So you're getting new best practices are automatically implemented in exit check. It's a great tool out there that we provide to you. So go ahead and use it. Go ahead and set up your notifications with database service events. If your CDB is down, your instance is down, listeners, backup failures, anything occurs, you want to be notified and aware of those database service events. Invest in your application failover readiness. As I mentioned, application continuity to protect those in-flight transactions. No changes to your application. Just go ahead and configure your connection string appropriately, have enable, have your fan enabled, all those type of things that you want to go ahead and take advantage of. And then as far as backups go, we recommend going ahead and letting us go ahead and manage those by default. Use DBA SCLI to go ahead and configure your advanced tuning. And we have a lot more options. You're going to hear about other things at Oracle CloudWorld this year regarding lower RPO and RTO with some new services that are on the horizon. So stay tuned for that. With that, let's go ahead and jump into gold. So gold is where we start to get disaster recovery, true disaster recovery. We can see this represented in the diagram. The technology under the covers is active data guard, right? So we have data guard, we have active data guard. Active data guard has more data protection than data guard. Some key features like application continuity that we just talked about with RAC for those in-flight transactions, part of Active Data Guard. And then we have automatic block repair that takes care of any type of corruption that occurs in a block. It will automatically fix it between standbys in the primary. So this is in addition to being able to go ahead and offload your queries as well. You can go ahead and offload them to your standbys. And you have the choice of local standbys and remote standbys. This goes back to our other discussion with the availability domains. And if you have multiple availability domains, it's very nice to set up a local standby. Synchronous replication, very easy to do without impacting the primary. Synchronous means that it's going to go ahead and wait for acknowledgement from the standby that's been written to disk. You also have fast sync as a option where you can just wait till it's written in memory before it acknowledges back to the primary to commit the transaction. It ensures 0 RPO. With synchronous replication. So that's our local standby. Remote standby, a lot of times it's further away. You, of course, could set up synchronous, which would even ensure basically 0 RPO in the case of a full site failure. So that's one option to you. A lot of our customers, though, go ahead and they use asynchronous instead because over the distance, waiting for that acknowledgement can impact the performance of the primary. So a lot of times what they'll set that up for is async from that perspective with the remote standby. Still providing a ton of protection. But it's up to you. You have the flexibility on this. And now we have the ability from an outage matrix standpoint to go ahead and plan maintenance, once again, 0 with our rolling patching. For upgrades, we have a rolling upgrade feature included in that data guard, implemented here, and it lowers our upgrade now down to seconds from an RTO standpoint. Recoverable failures, once again, RAC is still going to take care of this. Keep in mind, we're building on top of other tiers, so RAC is present, flashback, all those features are still there. And the real benefit that you get is with the unrecoverable failures, the site failures. Now look at that. We've dropped down to 0 RPO And now we have the ability to go ahead and just get seconds to RTO as well. We just do a role transition over there. And keep in mind, application continuity in there, once again, can go ahead and make this transparent to your application by replaying the transactions. It'll appear to be a blackout. No transactions that were in flight during when the primary failed, they won't go back up to the application. They can be replayed. Huge value add. All part of Gold MAA. So some best practice here. So active data guard. Once again, we always recommend active data guard over data guard because the advanced data protection with the automatic block repair, the application continuity, the DBMS rolling, all that you get there. Not that you can't use data guard as well. You always have these options available to you. And these are just basically suggested recommendation blueprints for you. Please configure your standby AWR so you can keep aware basically of your standby environments. This is automatically integrated for you today in our cloud deployments. We have a validate command built into our data guard broker that you can go ahead and run it weekly, schedule it weekly to go ahead and run. And then you really need to think about what kind of failover you want. Do you want the application to fail over, just the database? In other words, it'll go ahead and connect to another database, and the application, all the apps here will remain where it's at. This could be a lot of latency over a if you have a region-wide failure, your database was to jump over to the region, your application was to stay in the primary region, it could create a lot of latency there. So you may want to think about a full site switch. You may want to move the app tier over. So that's something to go ahead and consider how you want to go ahead and set that up. And you want to think about a DNS switch if you're going ahead and doing a full site switch. We also have a new service that's rolling out. At this point, it's in beta. Some of you have already heard announcements about it that we talked about the beta program of Oracle Full Stack Disaster Recovery. So there's a new service available that will go ahead and orchestrate that full site switch. That's a site switch fully integrates with everything we're talking about with Active Data Guard and all the database services. Now, you do not need to tune your redo transport. For those active data guard experts out there, you don't need to tune it. We go ahead, we have very high bandwidth networks here on OCI, and we'll go ahead, it's already taken care of for you. However, if your apply lag gets above 10 seconds, we do recommend taking a look at our best practices there, redo apply, troubleshooting, and tuning. They're best practices. You can find them just by searching for data guard best practices out there. We have a lot of new integration coming with fast start failover coming on some of the services, already available on some of the services that I mentioned out there, like Autonomous, but it's coming on some of the other ones. We have more health and auto repair that we're going ahead and building into it as well. And then a bunch of little features just at the PDB level with failover or DR and setting up DR tests. And that brings us up to our 5 nines. So our platinum, it's building on everything else. So at this point, we're trying to get to 0 across the board. And there's a lot of tricks to go ahead and do that. First of all, the technology that's used there. And we do have an alternative, which I'll talk about in a moment. But it's GoldenGate is the primary technology that we recommend here. And you have more than one primary in there. So we have 2 primaries in our diagram. This is a very simplified diagram. And then we have local standbys off both of those. You could also have remote standbys where the primaries are pointing at the opposite region to go ahead and replicate their standby to. Now, we have GoldenGate there between the primaries, providing bidirectional logical replication between them. It's asynchronous in nature. And then we have the local standbys. The local standbys are so you get all the benefits of Active Data Guard, application continuity, automatic block repair, synchronous replication. Depending on what you've gone ahead and set up, you have that option available to you there. So you basically can have your cake and eat it too. So there's some things to think about with conflict resolution between the 2 primaries. I like to use the example of sequences, right? You might want to use odd and even between your sequences if you have 2 primaries, for example. And there's other things to consider as well at the application tier when you're talking about a multi-master environment like you have here. You also could go ahead and have a load balancer do something like an active passive as well. We also like to recommend GDS, our Global Data Services, is a great technology to provide that load balancing in this environment as well. And it's all set up. We have papers and so forth that will give you guidelines to go ahead and configure GDS in the Platinum configuration. Our outage matrix looks just like we want it to, right? We're getting 0 across the board right now because we have 2 full primary environments that we can have up and running, and we can upgrade one of those at a time. So our planned maintenance is taken care of for us. Recoverable failures, of course, is taken up at this point, right? And then unrecoverable failures as well. We have full primary environments, right? And we can go ahead and direct accordingly. If your focus at this tier is more about online application upgrades, let's say you're only worried about the application. For you, gold is fine at the database level. But for the applications, I really want that ability to go ahead and do zero downtime application upgrades. We have another technology for you that might provide another option. The edition-based redefinition. Everybody has it. It's part of standard edition on the Oracle database. It's built into the database. Allows you to have more than one edition. Editions basically are logical projections of physical tables into, you can have more than one edition for a particular schema. Same is true for all the PL/SQL, all the store procedures underneath there. You can have those editioned as well. And you can have more than one application running against them. So you have your older version of your application, you have your new version of your application. They can be up and running simultaneously. We'll keep those editions in sync with something called cross-edition triggers. They'll have logical projections, so those two applications will be seeing something different, right? All the changes that you made. Once again, the idea is your application doesn't go against the physical tables. They go against the logical projections that we call editioning views. So this could be a bigger topic, and I have a lot of information out there that you can take a look at, including videos like this on edition-based redefinition that you can go ahead and check out. But it's another great option, and allows you not only to do zero downtime online application upgrades, but even have your older version of your application, your current version maybe, and the new upgraded version up and running simultaneously, and slowly move users over to it. So it allows you to go in and kick the tires and roll it out more slowly in a phased approach. A great technology. One thing I will point out is that GoldenGate in edition-based redefinition, or EBR, cannot coexist because the supplemental logging in GoldenGate conflicts with EBR. So it's one thing to keep in mind. You have to choose one or the other. Okay, a few best practices specifically on the GoldenGate side, right? We recommend you follow our best practices. Use DBFS because we have to keep our GoldenGate environment also in high availability. We have to make sure it's up. We have to make sure it's protected with DR. DBFS is the way to do that. We usually recommend doing it. You also have an option on premises. People use ACFS as another option. And we have Platinum MA guidelines out there to go ahead and tie in with it. Configure auto start for your GoldenGate processes. We have new papers coming out. This is an area of focusing. We're going ahead and automating more and more all the time with the Platinum. Right now in the cloud, you would have to go configure GoldenGate manually to set it up and follow all these guidelines. But we are creating more automation, so stay tuned on that as we go ahead and create more automation over time, associated specifically with configuring GoldenGate in this configuration. All right, the last one I want to go ahead and emphasize before we jump into a few other topics is the client-side technologies. How do I connect my application up to the database in the most appropriate way to go ahead and get most bang for my buck? So from a planned maintenance standpoint, you really want to do session draining. And it can be tricky with as far as a bulk workload against it as opposed to OLTP. With OLTP, the draining is quite simple. Application continuity takes care of this for you, in fact. And we can even set a drain timeout, and it will go ahead and drain out sessions until it goes in. It's timeout or it's done draining sessions before it disconnects a particular rack node, or in the case of Active Data Guard, the primary database. For unplanned downtime, obviously things go ahead and drop right on the fly, so it's going to go ahead and replay them over. So app continuity is going to handle that. It's going to connect up to the new rack node or the standby. It's going to go ahead and validate the connections there. It's going to replay the transaction and ensure that it only replays one time. One of the benefits of app continuity being built into the database, and it will take care of all this for you. We have an application checklist that you can check out, which will walk you through setting up for your application. All right, so as far as the automation, I want to jump into what type of cloud automation that we have and how it ties in with the different database services. So the one thing to keep in mind is we have a control plane built out there. It goes ahead and provides a UI, right, a GUI, as well as an Oracle user interface. We have a REST API, we have SDKs, we have Terraform, OCI providers, a lot of capabilities out there. We recommend you let us manage the service as much as possible. We implement all these best practices. Don't bring over all your on-premises scripts and everything to the cloud, because we automate a lot of this for you. You might be overriding it with your scripts. So we recommend that you go ahead and allow us to manage the service, depending on which service you choose. But Autonomous and ExaDB, for example, have a lot of automation built into them. You can go ahead and use the OCI tooling. You can do manual changes. You can set up multiple standbys, for example. A lot for BaseDB and ExaDB, you have a lot of flexibility on that. So we recommend you use that, but not when it conflicts with the automatic management that we provide. Here's as we go ahead and look at the different services, how it kind of plays out, right? We have the blue As far as the blue checkbox here, the out-of-box capabilities, right, for automatic backup, app services, those are built in. We take care of it. You don't even have to configure it. It's just completely taken care of for you. This is mostly in our autonomous services that we have, both shared and dedicated. Others, that green checkbox that we have indicate that you have different automatic backup. You can configure it as part of going ahead and deploying your service, right? So when you're deploying the database on that service, you have a lot of capabilities, a lot of flexibility to set things up. And there's some defaults in there on a lot of those. So a lot of those, if you just leave them alone, it'll be out of the box as well. And then there's manual. So a lot of different manual capabilities here. As far as fast start failover, the automatic failover capability it's required for some of the services. We have fast start failover for a few of the autonomous services built in. And then as far as, for example, if you want multiple standbys, you want that local standby and the remote, one of those would be manual as well. And that's indicated by that yellow checkbox. There's only one thing that's not available at all yet with our backup replicas on autonomous database shared that's coming soon. All right, let's go ahead and talk hybrid cloud and multi-cloud. So this is where I'm going to go ahead and finish up, but I think it's really an important area. As you go ahead and you think about getting up to the cloud, if you're not there yet, or you're going ahead and stepping your applications up there, hybrid cloud might be a stepping stone, or it might provide an extension to your existing data centers that you want to keep long-term. So we've seen both of this. This is very common for a lot of our customers. They might want to back up to the cloud, right? And we have a backup module that can be set up. You can decide whether you want to use rack or not, but we have single instance as well, right? If you're using base DB. Active data guard are all available to you and kind of key for setting up, particularly when we're talking about disaster recovery or migration. We'll talk about that as well because CDM uses data guard under the covers. GoldenGate is great, once again, if you're looking at Platinum, but it also is how you get up to the autonomous database. So if you want to set up hybrid cloud DR with autonomous database, GoldenGate's where it's at. I'll talk about that in a moment as well as we get into have a matrix that will walk this out. And then we have different MAA levels that are available. One thing that probably jumps out at you, though, is that we have bronze, gold, and platinum. What happened to silver? Well, that's answered on our next slide here. So the reason silver is not present there is because of the very nature, if we look at hybrid and the different options available to us. So if we look at base DB, for example, we can have single instance or we can have rack. Either way, if we're setting up disaster recovery, we're using ideally active data guard or data guard under the covers. So you have that set up there. So that is implicit that you already have that configured in your environment. So at the bronze level, you may not have rack, so it may not be a true silver, but you have bronze with a little bit of gold mixed into it already with data guard or active data guard configured here. Ideally active data guard for all the benefits I mentioned before. If we have rack in the picture, you're on premises with rack, you immediately jump to gold. No silver in there because, once again, active data guard is present. One thing to keep in mind with all these configurations, the control plane is not aware of the on-premises resources. So you're going to have to set up some of this manual as far as going to configure it. We have papers that walk you through all this on how to go ahead and set it up. And you can do non-Exadata up to ExaDB, but we usually recommend Exadata to the Exadata cloud, ideally. So that brings us to the Exadata cloud capabilities. We have Exadata, we have ExaDB on our OCI region, so let's give us gold. And then on autonomous, once again, GoldenGate is where it's at to go ahead and configure it as ADB shared or ADB dedicated. Now, maybe you have your application tier you want to run it on, or it's already running on a third-party cloud, but you want all the benefits of OCI. You want rack, you want all the protection that we provide with all these different options. Well, you can have your cake and eat it too there as well, right? Because we do support multi-cloud, and we have a recent relationship with Azure, with our interconnect regions that we've gone ahead and set up, and a bunch of other capabilities to go ahead and facilitate this. We also have partners, and one of them is highlighted in this slide, one of them called Megaport, which provides network latency redundancy as well as far as multi-tier. And we can see that's here. With a region 3, this would be a third-party cloud. Maybe all our application tiers, all the middle tier is running in there, and then it's integrated with the database cloud, maybe via Azure Interconnect to go ahead and set it up. And you can see a gold setup on the right-hand side, right? We have 2 regions, OCI Region 1, OCI Region 2. We have active data guard between them and async. We have a local standby with a rack. And then we have local standby or local backups as well configured. So this is one setup that you can have. And with that, I will wrap this up by saying I just went ahead and touched on things today with MAA. There's a ton of resources on there, the cloud, the database, Exadata, the database machine, and I love to highlight application continuity. It's a missing link that a lot of people are not implementing right now, and you already own it as part of Rack and Active Data Guard if you're using those. So please take advantage of it. We have a lot of papers up there, a lot of documentation and guidelines for you. And with that, I will wrap things up. I'd like to thank you. Once again, the name is Glen Hawkins, Senior Director of Product Management for Maximum Availability Architecture and Data Guard. You can reach out to me by email or my Twitter handle, HawkinsG1. Thank you.